Light passing from one medium to another bends or deflects from its original path. This phenomena is called refraction of light. The change in direction is caused by change in velocity of light in different medium. For example, if light from vacuum enter into another medium, it slows down. So if we divide the velocity of light in vacuum with the velocity of light in that medium, we get refractive index. Like water has a refractive index of 1.33. That means light travels 1.33 times slower in water than in vacuum. All the angles are measured from an imaginary line drawn at 90 degrees to the separating surface of the two medium. This is called normal. The effect of refraction or the amount of bending of light depend on two things. 1. Angle of incidence, and 2. Refractive indexes of the mediums. If the angle of incidence is more, the bending effect will be more, and the effect decreases with the decrease in angle of incidence. And if the light rays enter the medium at 90 degrees, there will be no bending of light. Secondly, refractive index of the medium affect the refraction. For example, light rays from vacuum enter two different medium with different refractive indexes. The medium with high refractive index will bend the light more. In this example, glass has more bending effect than water, keeping the angle of incidence same for both. Moreover, light when travels from lower refractive index to high refractive index, it slows down and bends toward the normal. On the other hand, light traveling from high refractive index to lower refractive index speeds up and bends away from the normal. When we dip a pencil in a glass of water, light rays from the tip refracts from the surface before they reach to the eyes. Our eyes trace the light back in straight line and it appears to be bent. The sky gets red during sunrise and sunset. Rainbows after a rain and mirage are some examples of natural phenomena caused by refraction. Refraction is used in lenses and prisms to manipulate light for different purposes. So this was about refraction of light. Like, share this video, comment your feedback in the comment section, check other videos here and subscribe to the channel.